Krishna Rao, Assistant Professor, CSC Department. I am handling the compiler design for the 5th semester. So in this class, we'll discuss the Lex program for the construction of the lexical analyzer. So we already discussed the regular expressions and finite data meter. Now we'll discuss how we use these regular expressions in constructing the lexical programs for the generating the lexical analyzers, right? So here, this is the structure of the lexical analyzer, right? So here, a specification of lexical analyzer prepared by creating the program lex.l, right? Here, lex.l is the first program we will write. We will compile with this one with the using lex compiler, which generate a C program lex.yy.c. Then this resultant one will compile with the C compiler, which produce the our C object program, the lexical analyzer, which generate the lexical analyzer, that is AOut, which takes the input sequence, and gives the a sequence of the tokens, right? So here our first we write that in the lexical source program. We follow the lexical rules of the source language that we represent with the regular expressions in this lex.l source program. And we use the lex compiler to convert this lex.l into the a C format program, lex.yy.c. This intermediate form will be compiled with the C compiler, will results to AOut, which results to AOut. This AOut is our lexical analyzer. This AOut is our lexical analyzer, right? This AOut is our lexical analyzer. What is the task of this lexical analyzer? It takes the input stream. And gives the a sequence of tokens. It takes the input, right? It takes the input string, and according it follows the lexical rules, and it will generate a sequence of tokens, right? So the source program will be the input for the lexical analyzer, and which gives the a sequence of tokens. How we are generating this lexical analyzer? We write all the patterns of the lexical rules of the source language in lex.l. That will be the input for our lexical compiler, which will give the C program. That will be input to the C compiler, which will generate the lexical analyzer. We take our source program, and it will generate a sequence of tokens. Here we will represent attributes and return values. These are the things we consider, right? L value is a global variable, right? So another lexical analyzer generation is Flex. Flex is another lexical analyzer generation, right? Here, the Lex program will consist of 3 parts. The Lex program will consist 3 parts. One is definitions, then rules, then third part user-defined subroutines. All regular expressions which we require will define in these definitions. All the definitions which are required will be defined in these definitions. Then, for which rule, which action has to take, for which regular expression which action has to take will be specified in this rules. For which rule, for which regular expression which action has to take will be specified in this rules, right? So whatever the functions subroutines that are required in this action part that are defined in this third one subroutines, right? So here first step definitions, second step the rules, third step user subroutines. So here it includes definition of the variables, constants, regular definitions, all are defined in the first part. The first part will consider the definitions of the variables, constants and regular definitions, everything, right? Here whenever the pattern 1 is formed, is encountered, action 1 will be taken. For regular expression or pattern 2, action 2 is considered. Here PA is a regular expression. Action is described what action the lexical analyzer should take when the pattern PA matches with a lexeme, right? So when that particular lexeme matches with the pattern, the particular action is to be considered. In that action, it may require some functions as subroutine. All such subroutines and functions are explained in the third part, user subroutines. Here it will consist all the functions which are required by the action part specified in the rules and regulation rules, right? So this is the structure of the Lex program. So all the declarations, all the translation rules and auxiliary functions, these are separated by these symbols, right? Double mod operator, right? The Lex program will be have three parts: declaration, first part, then translation rules, second part, auxiliary functions, third part, right? So these all the three parts are separated by these symbols which indicate the separation between these parts, right? So declaration consists definition of the variables and constants and regular definition. Here it will consist all the regular expressions and its actions. Then auxiliary functions which holds in the additional functions which are used in the action part, right? So here the structure of the lexical analyzer will consist three parts: declaration of the all the variables, constant and regular definitions. The translation rules which consist the regular expression. When that regular expression is matched with some lexeme, a respective action will be taken. So that are represented in the translation rules. So when that particular action is taking, it's required any functions and subroutines, all are defined in these auxiliary functions, right? We represent the patterns with the help of regular expressions, right? We use the patterns in the regular definitions. Whenever the pattern is matched, the respective action is taken. But how these patterns are represented? These patterns are represented with a regular expression. So here if we consider for the identifies a respective regular expression, letter followed by letter or digit closer of letter or digit, right? So here we can write a C code for this pattern. So whenever a particular lexeme matches with this identifier, it will perform respective action, right? So before writing a C code, we representing an intermediate form in the form of a transition diagram. Finite automata. So we have written a regular expression which matches to the patterns of the lexical rules of the programming language. That regular expressions now we are representing to in the form of intermediate form, the finite automatas, right? So any finite state automata may be expressed as computer program. Now we'll see how to write a program for this one. Start with a go to state 0, read a character. If C is a letter, go to state 1. Then what is this? Go to else simply go to state 0, right? This is a technique used by the Lex. Regular expressions as translated by Lex to a computer program that mimics the and finite state automata. So here we are converting the finite automata with a suitable C program, right? So we representing the patterns are lexical rules with the help of regular expressions. The regular expressions are converting to finite state automata. The finite state automata is converting to algorithms into C code. So we have written state 0. If it is a letter, go to state 1, right? Now, what is a state 1? If it's read C, go to state 1. If it is a digit, go to state 1. If not, go to state 2. So state 2 is simply accept string, right? So here we are converting the given pattern or regular expression to finite automata, and from the finite automata to respect to C programming code, right? So the previous algorithm for the identify we are converting to our C program, right? We are including header files, our main function, declaration of the variables, right? Enter and identify. So we are getting a string. If it is a alphabet, it's an alphabet. The first character alphabet, it's a flag is 1, right? If not, it is not a valid identifier, right? Here we are converting the algorithm for the pattern identifiers to a C programming, right? Here, first character should be alphabet. We are checking it is alphabet or not. If it is alphabet, the next characters we are checking is a digit or it is an alphabet. If not, simply we say it flag 0 and break, right? Otherwise, if the flag is 1, print it is a valid identifier. So this program code will check all the identifiers in the input source program, and it will says that it is a valid identifier or not. So like this, we can convert each patterns or lexical rules of the source program into respect to regular expressions, from the regular expressions to finite automata, transition diagrams, from the finite automata to algorithm steps, from the algorithm steps to the our C code. So this C code is a lexical analyzer which takes the input source program and it will give a sequence of tokens. From the source program, all the valid identifiers will be given as output, and if not, simply specify the input sequence of characters is not a valid identifiers, right? So if you enter the identifier first, it simply gives the valid identifier. If you enter the any other string starting with a digit, simply says it's not a valid identifier. So this will be the output of the previous our lexical analyzer program for the identifiers. Okay. Then in the rules section, we uses the some patterns Whenever the particular patterns are matched, then respective actions will be taken. If white spaces is the pattern it is matched, simply it perform skip all that white spaces. So here every pattern is matched with some particular action. So if that rules, the pattern is matched with the input sequence, then particular action will be taken. So here one more example. That same identifies letter followed by letter digit star. So if it matches, then simply printf it is an identifier. Right? So here this is one of the example for Lex program. What is a Lex program? The Lex program will consist three parts. That is declarations, translation rules, auxiliary functions. Right? That Lex program will consist these three parts. So here we are defining what is a number, what is an operator. Right? We are defining what is a number, what is the operator in declaration part. In translations, when these patterns or regular expressions are matched with the input sequence, then respective printf statements are printed. Printf number, printf operator. So here we are not using any auxiliary functions. So simply we are skipping the third part auxiliary function. Or you can say example. So input is 234. It's a number. If it is a star, it's an operator. If it is 2 plus 3, then number operator number. So for every input we are getting output. Right? So here in this auxiliary, in the rules section, if any pattern is matched, it's required to call the any subfunctions, that all subfunctions, subroutines, auxiliary functions is defined in the third part. Right? So here Lex is normally we specify as a subfunction. Right? So here Lex generate a C code for the rules specified in the rules section and places this code into the single function called Lex. Right? It will generate it. That lexical compiler will generate a C code for the rules and regulations. Right? So that will be in the Lex, and here the code will be written as lex.c file. Right? So here this is a file. In this one we can add the code. Right? Here this is an optional. If we not required, we can skip. Okay? Declaration, rules, and if there is no declarations, if there is no rules, simply we can specify skip them. But that separation is must. So here we are writing the main function which consists the private line, which will have the C code for that rules and regulations, right? And action part. Right? Here it is we are specifying declarations for the digit. This is a declaration for the digit. This is for the number. This is for the letter. Right? And here this is the one. Right? This is for the keywords. So first part is declarations. Then here it is a pattern. For the pattern we are printing the keyword. If keyword is matched, keyword is matched, then printf is given. Here this is the for the identify. Right? So the input sequence of characters that lexeme is matched with this pattern, then we printf the value is identified. Then if it is a digit, simply we print as digit. If it is a number, then we will print that number. So this second part is the translation zones. The second part is translation zone. Here, if it is required, we can use in the third part. It consists of the some our required functions, auxiliary functions. So whatever the auxiliary functions we required that are defined in the third part. So these are the three parts that we specify in the Lex program, right? So depending on the input, we'll get the output. If is the input, keyword is if. Int, keyword is int. If it is cache, identify cache. Because in the keyword, we are not specified the cache. So that's why it is giving as identify cache. 1 to 3, it's a number. If it's only 1, it's giving digit. Right? So by this one, I am completing the class. And in the next section, we'll continue with the other concepts. So the structure of the lexical program and the example for the lexical program that we discussed in today's class. And thank you. We'll continue in the next class.
Like, share and subscribe. Hit the bell icon for more updates.